Alrighty friends, welcome back to our last video of the week. So what I wanted to go into now is we're going to start talking about chapter 3. So we're going to talk about some of the features that we see on the seafloor in various marine provinces. And I would love for you to start by watching the video that I have linked, this TED Talk by Victor Vescovo. I have that linked right above this lecture video. I like starting there because I think it's really fascinating to see some of the deep sea exploration that is going on, not just by scientists, but also by folks with a whole lot of money. And so they're really investing in exploring the oceans and to have a better understanding of our planet. So I think that's kind of cool. So hopefully you've watched that and hopefully you found it really interesting. I think it's really quite cool. I know that the video is from 2019. I have looked a little bit further into Victor, and he is still doing same work or similar work, and has done lots and lots of dives now. I think the last one I saw, he's now dove 15 times down to the Challenger Deep, which is pretty impressive. So kind of cool too. And he does a little dig at Elon Musk. It's pretty funny. Anyways, so on to our lecture. So what's kind of cool is even though there's not a whole lot of the world or a lot of the oceans that have really been fully explored, and what I mean by that, I mean like literally going and scouring every little inch of the ocean floor. But we've been able to start mapping the ocean floor and creating what are called bathymetry maps, which is basically just if you were to take all the water out of the ocean, it would be what the bottom of the ocean looks like from above. Almost like trying to find like all the mountain ranges and mountains and valleys underneath the water. So we're able to do that in several ways. The first is by doing an echo sounding record. So you can think of that as something kind of like, almost like how bats use echolocation, or some different types of like whales and stuff, how they use echolocation. They put out a sound, and how fast that sound comes back is how close that object is. So we've done that before for under the water. And then we've also used scanning sonars off of boats, and that can give us a bit better of a good three-dimensional sort of view of under the water. And then last thing, or a couple more things, are mapping the seafloor from space through satellites. So satellites are freaking awesome pieces of instruments that do so much to monitor our planet. And these ones in particular are able to pulse out radar pulses, and they're able to tell us kind of where the bottom of the ocean is and where some of the sea levels are rising and where they're not, kind of where we see these gyres and almost like water mountains in a weird way. But while those are great, they can kind of not be super accurate, which is kind of scary. Or not scary, scary is definitely not the right word, but that's kind of why we like to use more of the in situ measurements from like ships or from sonar, things like that. The last way that some scientists use to map the ocean floor, and this way is a bit controversial, is from seismic reflection. So basically they'll create an explosion or an air gun, and that will penetrate, that sound, those waves will penetrate through the water and then also into the rock. And the further down the rock the explosion waves go, can tell us a little bit more on the density of the rock, how far does sound go into it, and then once it's reflected back to the receiver, can the amount of time that it takes to do that, very similar to like an echo sounding, but just with a much greater noise. And you could likely imagine that the most controversial of these methods is the seismic reflection. Any sort of big boom underwater can be very detrimental to any animal that it has to use hearing to communicate or use singing to communicate to other pods or clicking, whatever, what have you. It's actually rather sad that sometimes with some of this, some of these methods is it can actually be very, very harmful for the animals that live in these regions. Some dolphins and some whales have actually gone deaf from these explosions, and that can then they will starve because they can't see food or can't find their families, and then unfortunately they can then die and then become beached. It's a very, very sad thing. So and even with sonar, unfortunately, those are really, really loud pings underwater. And again, can be very, very hard of hearing, or it can basically make animals go deaf, which is really crappy. And so if we were to look at a map of the bathymetry around the world, not just including underwater, but above water as well, so we can see like where there's huge, mountain ranges and things like that, but we can visualize what's going down underneath the water. So some really interesting things I think to point out, of course, are the Hawaiian Islands, but we can also see how those are extended further out and up into this other island chain that connects with the Aleutian Islands of Alaska. There, of course, is some missing data here where things would be a little bit flatter. You can also see quite nicely how the Arctic Ocean is rather shallow. So the red colors under the water indicate shallow conditions, and the cooler colors indicate deeper conditions. So kind of a neat thing here. Excuse me. And we can also see the mid-ocean ridge down the Atlantic Ocean and the East Pacific rise. So just a lot of really, really neat features that we can see under the water just by making these really beautiful bathymetry maps. So, considering all of that, how we've been able to map the bottom of the ocean, I want to go into some of the various marine provinces that we can see. A very simplified version of all of these. Of course, things are a little bit more complicated, but the three main marine provinces include mid-ocean ridges, the deep ocean basins, and continental margins. So if we were to take a slice of the Atlantic Ocean, the northern Atlantic Ocean from North America to Africa, this is kind of what we would see underneath in this little cross-section here. So what I'm going to do for the rest of today's video is concentrate on the continental margin. So there's differences between coastlines and just some features that we see right along the coast. And then we'll dive deeper into the ocean basin floor and then some of the features we see along the mid-ocean ridge as well. So starting here near the coast, these are called continental margins. So most continental margins are made up of three main features: a continental shelf, a continental slope, and a continental rise. So the shelf is what is closest to the above water part of the continent. Generally is quite flat, can extend anywhere from 30 miles to hundreds of miles, depending on which coast you're on. Then there's a shelf break here, and then we have our continental slope. The way that I like to remember a continental slope is thinking of like Finding Nemo and the drop-off, right? You know how Marlin freaks out about Nemo going to the drop-off, yada, yada, yada. It's basically literally looks like a straight-up drop-off, where then it goes into the continental rise and then way, way, way later into the abyssal plain. So when we're considering the continental margins, we have two main types of margins here. And it really, I don't know, kind of the main way that I can remember these two different types of margins. They're called passive margins versus active margins. So passive margins are margins that are embedded within the plate, and there's no tectonic activity, no volcanoes, no underwater trench, and a rather prominent continental rise, and also a very, very wide continental shelf. So that's kind of the passive area. Think of like being a passive person. You kind of just like let everything roll over you. You're not doing any sort of activity. You're just kind of there, right? Whereas for active margins, they are actually at the edge of a plate as opposed to being embedded in them. There's quite a bit of tectonic activity. There's volcanic arcs or ancient volcanic arcs. There's likely an offshore trench, a very narrow continental shelf, and little to no continental rise. So I want you to take a quick pause and think to yourself what we would observe here on the West Coast. Would we be an active margin or a passive margin? And why? So pause the video for just a second and have a moment. And then we can also revisit our maps of the boundaries, the plate boundaries of our convergent and divergent boundaries. And if we consider the west coast of the U.S. versus the east coast of the U.S., which one is on a more active plate boundary? The west coast is on a more active plate boundary, tectonic movement, right? For me, I think that's the easiest way to remember that the west coast is on an active continental margin because we have all the earthquakes, right? We're right on that fault, right? Whereas the east coast of the U.S. is not near a plate boundary. There's no ancient volcanic arcs in their mountains. There's no tectonic movement, and there's no underwater trench. The underwater trench one is kind of hard for us to imagine, perhaps because maybe we aren't familiar with what's happening underneath the water necessarily, or we don't really know if there's a trench right there. But if we were to look down in South America, there is actually a similar idea here of the west coast of South America is active, the east coast of South America is passive. And if we were to look under the water off the coast of South America, there's a huge Peru-Chilean trench off that west coast there. So we have the Andes Mountains over here on the right and the Peru-Chilean trench here on the left. So it's a really nice visual of that. If you're in my lab, we're going to make cross sections and look at this more deeply. But here, just in the lecture, just knowing kind of baseline, those kind of variations between those areas. And then if we looked again here on the east coast of the United States, it's more passive. We've seen this image a couple of times now, but what I like to show here is just how smooth right off the coastlines are. We don't have these wrinkles immediately right off the coast, right? There's a much, much, much wider continental shelf area. And again, if you're in my lab, we will most certainly look at that in a deeper fashion. If you're in my lecture, it's just kind of baseline. Just remember the east coast of the U.S. is passive. The west coast of the U.S. is active. All right. And when we come back to class, we will continue on our discussions of marine province regions. All right. Thanks so much for watching. Bye.